All right, so we're going to start off this year by talking about equations. I think maybe in the third 9 weeks of last year, you all looked at 1 and 2 step equations. I'm going to just do a recall on 1 step, and then I get into the lesson that we'll do a review on 2 step. Then we'll move to multi-step, which will have some distributive property and combining like terms. And then I'm going to get into some that have, excuse me, guys. I'm going to get into some that have fractions in them, and I'm going to show you how to get rid of those fractions, okay? Let me turn this sound off. All right, so let's just look at these 1 step equations. So first of all, we need to talk about inverse operations and just talk about what are they. Inverse operations are operations that undo each other. And if you're going to solve equations, it's important that you know inverse operations. So if you want to undo addition, well, what do you think you would do to get rid of addition? You would use subtraction, and vice versa. If you wanted to get rid of subtraction, you would use addition. If you wanted to get rid of multiplication, the opposite of multiplication is simply division. And then vice versa. If you wanted to get rid of a division, you would use multiplication. And the whole goal when you're solving an equation is to get the variable by itself. So some people just say, just isolate the variable, okay? All right, get the variable by itself. So basically, you need to be working with the numbers on the side with the variable. So I always draw this line. So I see on this side with the variable is -5. Well, how do I get rid of -5? Well, I ask myself, what is -5 doing to x? When they're mashed together like such, the way they are, that means that -5 is multiplying x. And sometimes we mash them together instead of using the multiplication sign. So the opposite of multiplication is division. So I'm going to divide by -5. Now, in an equation, to keep things balanced, what you do to one side of an equation, you must also do to the other side. So if I divide the left side by -5, I also have to divide the right side by -5. Keep in mind, I did not change signs. I'm not dividing by +5. You only change the sign if you are adding or subtracting. This is multiplication and division. So you're going to have x equals to 9. A negative divided by negative is a positive. If you forgot your multiplication rules, just use the smiley face. The smiley face works for multiplication and division rules, okay? A negative divided by negative leaves you with a positive here. Now, number 2, I don't like that negative being with the bar. So what I'm going to do is rewrite this problem and put the negative with the number itself. I'm going to put with the 4. Now, I notice that I have my variables on the right side this time. It doesn't really matter, but I notice my variables on the right side. So I ask myself, what's keeping me from having that x by itself? Because the whole goal is to get the variable by itself. Well, what's keeping me from having x by itself is -4. Okay, so I need to see what -4 is doing to x. Well, -4 x is being divided by -4, okay? So what is the opposite of being divided by -4? So instead of dividing x by -4, I'm going to multiply by -4. But what I do to one side, I must also do to the other side to keep the equation balanced. These two will cancel. And I have -4 times 12, which is -48. Again, that's multiplication, so I can just go back to the smiley face. A negative times a positive leaves me with a negative. Okay, on number 3, it's really simple. What I'm going to do is set up like a proportion. That's when you got two fractions that are equal to each other. I don't know if we got to this the fourth 9 weeks or in the third 9 weeks. I don't remember, but I'm just going to go through it. With a proportion, you just cross multiply. So 4 times 5 is 20. I'm going to multiply here. -3 times x is -3x. All right, so what I want to do now is look at what I have. Well, I have multiplication. There's multiplication right there. I want to undo that. Okay. I was trying to use this. Here's multiplication. So I want to divide. I want to use an inverse operation, which is division. All right, so instead of multiplying x by -3, I'm going to divide it by -3. These will cancel. And then how many groups of 3 can I get out of 20? Well, I can get 6 groups. And it's going to leave me with a remainder of 2. So that's going to be negative 6 and 2/3. Now, I could have written this as a repeating decimal. As a repeating decimal, it would have been negative 6 and 6/10 repeating with the bar over the 6. Like that. Okay, let's take a look at number 4. If you look at number 4, you can put an imaginary 1 underneath that 7, but I'm going to show you how to work it without setting up a proportion, okay? If you put an imaginary 1 underneath the 7, you could just use cross multiplication. But I want to show you a different way because I showed you the cross multiplication way on number 3. So what I could do is, so a lot of students would think you multiply by 2, but x is not being divided by 2. 2 is actually being divided by x. But what I'm going to do is get rid of a variable. Anytime you have a variable in your denominator, you can get rid of it first by multiplying both sides by that variable. These will cancel, so I end up with x times negative 7, which is negative 7x equals to 2. Now, what is the opposite of multiplying x by negative 7? Well, that would be dividing it by negative 7. So x is equal to negative 2/7. Or you can write it like this. Or you could put it like this. You could put the negative with the 2. It doesn't matter. X is equivalent to each one of those. Okay, since 7 won't go into 2, that's the way it works out. Now I'm going to show you something on number 5. I'm going to rewrite it because I don't have enough room to do what I want to. Anytime you have a fraction attached to your variable, and here's a fraction attached to the variable. See, negative 3/5 is a fraction, and it's attached to x. You can multiply by the reciprocal to get rid of that fraction. So I'm going to multiply both sides by the reciprocal of negative 3/5. The reciprocal just means the inverse if you flip it. So if you flip negative 3 over 5, you end up with 5 over negative 3, but I'm going to leave the negative with the 5. But what you do to one side of the equation, you must also do to the other side of the equation. You're going to end up with 15 over 15, which is 1. So basically, these just cancel each other out. On the top, when you multiply here, you end up with negative 10/9. And that will go approximately, you can get 1 whole group of 9 with a remainder of 1. So that's 1 and 1/9. And now you can write it as a repeating decimal. It's negative 1 and 1/10 repeating. Okay, let's take a look at number 6. If you look at number 6, again, there is a fraction attached to the variable. Here's the variable, and there's a fraction attached to it. So again, I'm going to multiply by the reciprocal. I'm going to write this so I can have some room to multiply by the reciprocal. But what is the reciprocal of 3/4? Well, that would be 4 over 3. So I'm going to multiply both sides by 4 over 3. I'm going to go ahead and put an understood 1 there. So I end up with negative 48 over 3. These will cancel because you end up with 12 over 12, which is 1. Now, when you divide, you get negative 16. And that's that. Now, what I do want to show you is just briefly, if I got enough room, addition and subtraction. So I'm going to go down here and just kind of look at that one more time. All those at the top were multiplication and division problems. But if I gave you something like this, well, here you're at 7. So what's keeping me from having x by itself? Well, adding 7 is keeping me from having x by itself. I always say if it's addition or subtraction, the best thing you can do is just change the sign. So I'm going to change the sign of positive 7 to negative 7. Or you can say the opposite of adding 7 is subtracting 7. But I always like to think of it as 7 positives, or if it was another number with a negative, it would be 7 negatives. All right. Now, these have the same sign. You wouldn't use the smiley face on this because this isn't multiplication division. The smiley face only works on multiplication division. Here you have to say they go in the same direction or they are the same sign. I taught direction. Some of you may have learned that they're the same sign. Well, in the case when they are the same, you add and keep the sign. So basically, if you're 22 units on the left side of 0, you're on a number line. and you go 22 units to the left, and then you got to go 7 more units to the left because you're subtracting 7. Well, you're going to be 22 units to the left and 7 more units to the left of 22, which is going to put you at negative 29. So basically, when the signs are the same, you add them and keep your sign. I taught this is on the left. I would have to move to the left. So if you're moving in the same direction, you add. And the only place that it could be is if you're to the left, you start off, you're going left 22 from 0, and then you go left some more. The only place that you could be in relation to a number line is on the left side of the number line. You haven't even moved to the right, which means you're on a negative side. If I gave you something like this, then I just say the opposite of a minus 12 is a plus 12, or the opposite. I often say the opposite of negative 12 is a positive 12. These cancel. Basically, if there's a plus or a minus sign in between your variable and number, see, there's your variable, there's your number. There's a minus sign. Here's my variable, here's my number. There's a plus sign. If there is a plus or a minus in between your variable or your number, that just simply means that it's an addition or subtraction problem, and you need to change the sign or whatever is on the side with X. Make sure you're working on the side with X first, or the side with that variable. Now, these have different signs. This is 18 units to the left on a number line, but this says move back 12 units to the right, okay? You're not going to end up being more negative. Actually, you're taking some of those negatives away because you're adding positives. So if you're at 0 and you go 18 units over here to negative 18, and you have to go back 12 units, I don't want it to go that far. And you have to just go back 12 units. It's not going to put you back at 0. It's not even going to put you on the positive side. You're still going to be on the negative side, so it's going to be negative what? Well, what do you do if they go in opposite directions or they have opposite signs? Opposite signs or directions, because I taught directions last year. Then what you want to do is subtract and take the sign of the larger group. And I say larger group because you may have a larger group of negatives, or you may have a larger group of positives. I'm not going to say larger number. Well, so if I look right here, I have 18 negatives and only 12 positives. So the larger group of numbers is the negative group. So it's going to be negative 6. All right. We need to talk about what if you have 2 signs. So let me erase this. If you have 2 signs in between your number and your variable. For example, if I have x plus negative 3 equals to, let's say, negative 15. Well, if you have 2 signs here, you see you have that plus, and then you have a negative 3. Okay, you can just look at this. Worry about that negative 3 right here, okay? Don't worry about the plus. So I just want to worry about this negative 3. Well, how do you get rid of 3 negatives? Well, you want to add 3 positives. So when you have plus negative, don't worry about the plus. Just get rid of the number inside of parentheses if there's a plus sign in the middle. These are going to cancel, so this x equals to negative 12. Okay, if I gave you an example that looks like this, suppose you had, we'll say 18 equals to x minus negative 10. All right, so what I have my students do, if they ever see minus or negative, I automatically have them write that as a plus. Automatically, that will become a plus. So I'm going to rewrite this as 18 equals to x plus 10. I don't put plus 10 underneath this negative 10 here. Some people saying, what's in parentheses? I just change the sign of the negative 10. No, you don't. If you have minus or negative, that's a special one. Minus or negative is the same as plus. Okay? All right, now you can do the opposite. Opposite of plus 10 is negative 10. So basically 8 is what your value of x would be. All right, that's just a review of some one step. Now we're going to actually go to our lesson. And I'm going to go through two step. And if you look at this standard, it says that, and this is what we're going to work our way to, guys. We're basically just doing some groundwork right now until we can get to this, all right? So what we want to do is give examples of linear equations in one variable with one solution, and these will all have one solution. Infinitely many solutions or no solutions. Now we'll get to the infinitely many and no solutions on Friday, I hope. So show which of these possibilities is the case by successively transforming the given equation to simpler forms until the equation is equivalent into one of these forms. I know you don't know what this means. I'll talk about it later. X equal to A basically is just one solution. I might as well go and talk about it. Where you have one solution. A equal to A, when you get one number equal to another number and you don't have a variable in there anymore, that's going to be infinitely many. And A equal to B, where you got one number that's different from another number. That means there's actually no solution. And when you get these answers to these equations, it just means this is the answer that will help this equal to 3. Or if I get an answer to this one, whatever that answer is the answer that will help this whole thing equal to 1.5. All right, it says on B, solve linear equations with rational number coefficients. That's why I'm going to get to the fractions last. Rational numbers are any numbers that can be converted to fractions. So I'm going to get to some that actually have fractions in the end of this lesson, okay? We're going to make sure we expand expressions. We're going to use the distributive property. We're going to be, it says collecting like terms. I call it combining like terms, okay, guys? All right, so here we go. Just a review. You should already know this. I like to put my line there. I don't like to, okay. All right, now this is a two-step equation. So it's going to take 2 steps to get the x by itself. So I have to think about what 2 things on this side, on this left side, are keeping me from having x by itself. Well, that would be -4 and -7. So which one do you get rid of first? Well, you always get rid of the one that is farther from your variable. So here's my variable. Okay, my variable is right here. The -7 is really close to the variable. -4 is farther away. So I always get rid of the one that's farther away. Well, how do you get rid of the one that's farther away first? In most instances, you get rid of the one that's farther away just by changing the sign. Excuse me. So I'm going to change -4 to +4. Well, it needs to look a little better than that. Okay, I know what the problem is. Hold on, guys. So I'm going to change -4 to +4. What I do to one side, I also do to the other. These will cancel, leaving me with -7x equals to 7. But this is multiplication, so the opposite of multiplication is division. You're back to a one step, which is what I showed you in the beginning on that do now. We use the smaller face. So positive divided by negative leaves me with a negative. So 7 divided by 7 is 1, but it's -1. So what I'm going to do a check, and I'm not going to make you check yours, but I'm going to show you how it works. Instead of writing an x right here on the next line, I'm going to write -4 minus 7 parentheses. That's multiplication. And I'm going to change my x to -1 equals to 3. So we end up with -4. A negative times a negative is a positive. -7 times -1 is +7. Well, this left side is going to equal to 3. So basically, it checks out. The only number that makes this left side equal to 3 is -1. Now, you don't have to check these, but I'm showing you when you solve these equations, basically what you're doing is finding out what value of x or y, whatever your variable is going to make the left side equal to the right side of the equation, all right? That's all you're doing. All right, we're going to keep going because you're in my advanced class, so, I mean, we should know this already. right, the first thing I want to do is get rid of the one that's farther from y, which would be negative 5 7/10. To get rid of it, you just change the sign. The opposite of minus 5 7/10 is adding it. These will cancel, so I end up with 1 2/10 y equals to 7.2 or 7 2/10. The opposite of multiplying by 1 2/10 is dividing. These will cancel. You simply end up with 6. Now, if you don't know that, you have to push your decimal. You can't divide by a decimal. You can only divide by a whole number. So I'm going to push this decimal once. But I call it monkey see, monkey do. If this one wants to swing once, this one only swings once. So this one on the inside here copies what this one does. So if this one moves once, that one moves once. If this one moves twice, that one will move twice. And so forth. So basically, you're looking at 12 into 72, which we all know is 6. All right, let's take a look at number 3. Looking at number 3, which one is farther from n, but yet on the side with n? Okay, so you got 5, and then I'm going to say negative 7 or minus 7. 5 is farther away. So what I'm going to do is go ahead and get rid of the 5. To get rid of the one that is farther away, like I said, in most cases, you just change the sign. The opposite of 5 is negative 5. Most people will have a tendency to put plus 5 right here because they're looking at the middle sign. I don't care about that middle sign. I'm looking at the number that's farther away, which is 5. What is the opposite of 5? Negative 5. What I do to one side, I do to the other. I'm going to take that negative and put it with the 7 so it looks better instead of being with the bar. These go in the same direction. They both go to the left. Or they both have the same sign. Okay? However you want to look at it. I don't know how Ms. Brown taught you last year, but I just taught direction. That goes left. And that goes left. So if I'm on the left, I know I'm negative. Negative what? I'm at negative 9. I'm talking about on a number line. 4 units to the left of 0 and 5 more units to the left of negative 4. Puts me at negative 9. Now, this is division on the left side. So the opposite of division is multiplication. So instead of dividing n by negative 7, I'm going to multiply it by negative 7. Remember, you're not changing the sign unless you're adding or subtracting. This is multiplication and division right in here, okay? It's multiplication and division. All right, so a negative times a negative leaves us with a positive 63. All right, let's keep moving. All right, I see right here I have that minus a negative. I call it a double negative. I'm automatically going to rewrite that as a plus before I even start. Then I'm going to say, well, which one is farther from x? Well, that would be, see, the negative 3 is like mashed together with it. So they're really stuck together. X and 9 are separated by a plus sign, so 9 is farther away. So I'm going to change 9 to its opposite. Change the sign of the one that's farther away. So you have negative 3x equals to negative 21. Same signs, add and keep the sign. The opposite of multiplying by negative 3 is dividing by negative 3. So that puts me at x equals to a positive 7, guys. All right, number 5 has a fraction in it, but we don't worry about the fraction right now. What you want to do is get rid of the one that's farther away from x, but yet on the side with x. Please don't try to get rid of this negative 9. It's not even on the side with x. So if the whole goal is to get the variable by itself, what is getting rid of negative 9 going to do? It's going to put it over here. That's more stuff over there with the x. All right, so what I'm get rid of the one that's farther away, so I want to add 5 to both sides. We just change the sign to get rid of the one that's farther away. So you have 2/3 x equals to negative 4. Remember, this is to the left. And if you add 5, you would move back to the right on the number line. If they go in different or opposite directions, you just subtract and keep the sign of the larger number. I don't want to say larger number. And keep the sign of the larger group. All right, now, whenever you have a fraction attached to your variable, you can get rid of it by multiplying by the reciprocal. So the reciprocal of 2/3 is 3/2. So I'm going to multiply both sides by 3/2. These will cancel. That will give me negative 12 over 2. And everybody knows that negative 12 divided by 2 is negative 6. I hope we all do. And keep in mind, if you're doing division, just go back here and you can use a smiley face. A negative divided by a positive is a negative. All right, number 6 is a tad bit different. I'm going to rewrite it. And I want you to notice that in this problem, you have minus and negative. So if you have minus and negative, what did I say automatically I want you to do with it? It's a double negative. I want you to fix that. I want to rewrite that as a plus. Okay? That will become a plus. Instead of writing those two signs, I'm going to write a plus sign instead. All right, so I'm going to rewrite this as negative 5 equals to negative x, 9x plus 1 divided by 7. Okay, now I know I said what we do most of the time is just change the sign, but we're not going to be changing the sign here because if I try to go on in here and change the sign of the 1, I'm going to be right on top of this problem. Minus 1, minus 1. It doesn't make any sense. It doesn't even look right. You're right on top of the 7. Okay, so we can't do that. Basically, that 7 is in our way. So since that 7 is in our way, let's not do that. And if something is in your way, what do? First of all, you got to move it out of the way before you can get to something else. So how do I move 7 out of the way? Well, if you'll notice right here, 7 is dividing this stuff. It's all this stuff is being divided by 7. So instead of dividing all this stuff by 7, I'm going to multiply it by 7. But if I multiply that side by 7, I also must multiply this this side by 7. Now look, guys, I don't want you to get these two mixed up. Somebody's going to say on this particular problem up here, if I can find it, on number 3, look at it. Somebody might say, well, why didn't I multiply by 7 first right here? Because all of this was not being divided by 7. It's not like it was written like this. No, it's written like this. Only the n is being divided by 7. So it's easy for me to get to the 5. I can go up underneath the 5 and cancel it out. Now, I couldn't go up underneath the 5 here and do it because then that 7 is in my way. So I hope you all understand what I'm saying. You can't have stuff. If you're trying to get to a number and change the sign or add or subtract, but you got a number in the way, then get rid of that number first, okay? All right, let me erase this. All right, so these are going to cancel. And I'm going to go up here. So 7 times negative 5 is negative 35. I have negative 9x plus 1. And that's going to be fairly easy. Now I can get rid of the plus 1. Now I can go to it. And I'm not writing all over another number. These will cancel. Same direction, same signs. Add and keep the sign. Here I'm left with negative 9x. Now to get x by itself, I just need to get rid of that negative 9. So I'm going to divide both sides by negative 9. 4 is equal to x, or x is equal to 4. All right, on number 7, I'm going to get rid of the one that's farther away from x, and that would be this negative 7/10. I'm going to add 7/10. Now, I'm not going to keep that negative that's with the bar. I'm not going to keep it with the bar. I'm going to put it with that negative 5 and 32/100. So that gives me 9/10 when I add 2/10 and 7/10. Now, what is the opposite of dividing by negative 5 and 2/10? Well, that would be multiplying x by negative 5 and 2/10. But what I do to one side, I also do on the other side. I don't like all those decimals and time signs. They start looking alike. So I'm going to write this another way. Just write it with a parentheses and mash them together. Okay, those cancel. And to multiply decimals, I just do it this way. I just take the decimal out. I multiply this as 532 times 9. I'll put the decimal back in a second. And so that's going to be 18. 27 and 1, that's 28. 45 and 2 is 47. So what I'll do is I just count the number of decimals that I see in the problem. Number of numbers behind the decimal I see in the problem. 1, 2, 3. So I have a total of 3 numbers behind the decimal. So I need a total of 3 numbers behind the decimal here. That means my decimal is going right there. Now, negative times a positive is a negative. So it's a negative 4 and 788 thousandths. And that's it, guys. That's how you do that. All right, so I'm going to go on to some multi-step. What I just did was just a review of what you should have already learned in 7th grade. All right, to solve multi-step equations, it's pretty simple. What you want to do first is you want to remove parentheses by using the distributive property. So if you see any parentheses, that's the first step. And guys, I want you to make sure that you pause this video and you take notes too, especially on this part, okay? Take notes on notebook paper. All right, so after you remove parentheses by using the distributive property, the next step will be to combine any like terms. Now remember, to have like terms, they got to have the same variable and the same exponent, corresponding exponents, okay? You can't have like x and x squared. Those are not like terms just because you got an x and an x. You got x and x squared, so that won't work. All right, and then what you're going to do is solve, because basically you'll probably have it down to a two-step equation, okay? How do you solve an equation? By using, let me write that a little better. Inverse operations, okay? All right, so if I look at number one, I'm looking over here on the left side because I see my variables over here, but I don't see any parentheses. So I'm going to totally skip step one and go to step two. I'm going to combine any like terms. Well, I see some like terms. 9x and negative 7x. And I look at this as negative 7x. I don't look at it as minus 7x. So 9x minus 7x is 2x. And I also see other like terms. So your constants are like. So that's 1 and negative 5, or 1 minus 5, which will leave you with minus 4. Now, you're basically down to a two-step equation, which is what I just got finished reviewing with you all. So now you're able to look and see, oh, what's farther from my variable? Well, this negative 4 is. How do I get rid of something that's farther from my variable? You change the sign. So I'm going to change the sign. So we end up, since these are different right here, they're going in different directions. That's 20 units to the left, and you only go back 4 units to the right if you're on a number line, which means you're still on the negative side and you're at negative 16. Then you're going to divide both sides by 2, because the opposite of multiplying by 2 is dividing, so x is simply equal to negative 8. All right, let's move on. On number 2, I do see parentheses, so I'm going to use the distributive property. So use the distributive property. You're going to multiply everything inside the parentheses by the number that's outside. Negative 7 times 3 is negative 21a. And negative 7 times negative 1. Look at this as a negative 1. Negative 7 times negative 1 is a positive 7. Now I have a basic two-step. Well, which number is farther away from the a? That would be 7, because negative 21 is like really stuck to a, okay? 7 and a are separated by a plus sign, so I'm going to change the sign. So you end up with negative 21a. Okay, I'm going to have to write that better, guys. And then when you do 91 minus 7, you end up with 84. The opposite of multiplying a by negative 21 is dividing a by negative 21. Remember, don't ever change the sign when you're doing multiplication or division with equations, okay? So a is equal to negative 4, and that's that. All right, let's take a look at number 3. Number 3, I see parentheses too, and I'm going to tell you what I don't want to see. I don't want you to try to put 4m with 5. They're not even like terms. The very first thing this says do is remove parentheses by using the distributive property. So I don't care about this 4m right now. So I'm not even going to focus on that. I'm just going to write it back down, 4m. So I have to remove this part first. I got to work with this. I got to use the distributor property right here. You're not distributing 5. You're going to distribute, look at this as -5. So you're going to distribute a -5. I know it says -5, but look at it as -5, okay? -5 times 3m is -15m. If I say -15m, I write -15m. -5 times +10 is -50. If I say -50, I write -50. Now I want to move on to step 2. Well, step 2 says, after you remove those parentheses, combine any like terms. Well, do I have like terms? I sure do. 4m and -15m. Okay? These two. So it's like 4 minus 15. You 4 to the right of 0, and then you go back 15 units to the left. Well, you're going to go past 0 on the negative side if you're on a number line. So that's going to put you at -11m minus 50 equals to 126. All right, so the number that's farther away from m is that -50. So I'm going to change the sign. So -50 goes to +50. These will cancel, so I'm left with -11m equals to 176. And some of you probably have worked this out already. You're past me. If I can get this to erase, guys. Okay, there we go. All right, so I got my 176, and I want to divide by -11. The opposite of multiplying by -11 is dividing by. Remember, when you multiply or divide by a number, you're doing solving equations. You're not changing the signs. And so we have 176 divided by 11. We're going to end up with -16. And I'm sure at home you're using your calculator, but if you have to do long division, do long division. 11 will go into 17 once. The remainder is 6. Bring down this 6. 11 goes into 66 6 times with a remainder of 0. All right, let's take a look at number 4. Number 4 has 2 parentheses in it, 2 sets of it in there. So what I'm going to have to do is use the distributor property twice, not once. So first of all, I'm going to take care of this part. So I'm going to distribute the -3. Well, you distribute the -3 to the k and to the -8. Don't look at that as -8. Look at it as -8. Then you're thinking, you go over here, and this looks really weird. Like, there's parentheses right here, but what's out here to distribute? Well, you put an imaginary 1 when you see nothing out there to distribute. But if you see a negative sign, there's nothing to distribute, put a 1 there. Or if you don't see, even if you see a plus and it makes you feel better to put a 1 there in front of that parentheses, go ahead. So I'm going to distribute that -1 to the k and the 5 there, okay? Now let's take care of this part. -3 times k is -3k. -3 times -8 is +24. And then I'm going to work over here on this side. -1 times k is -1k. And -1 times 5 is -5. Now I've gotten rid of all the parentheses, okay? Gotten rid of them. They're gone. So now I'm going to combine like terms. Well, they're my like terms. They're -3k and -1k. All right, so that's going to give me -4k. They're the same direction. And then I also have constants that are like 24 minus 5. Okay, we end up with 19. Equals to 23. All right, so I'm going to get rid of the 19 that's farther away. These will cancel. I'm going to have to go up here, guys. So I have -4k equals to 4. Now, what is the opposite of multiplying by k by -4? So instead of multiplying k by -4, I'm going to divide k by -4. But what I do to one side, I also do to the other side. And k is equal to -1. All right, I'm not really going to work 5, 6. I will work 7. Let me do 6. I'm going to have to skip some of these, guys, because I don't know how long I've been on here, 39 minutes. I don't want to take up your whole hour, okay? We're going to work 6. It's going to distribute here and here. You only distribute in the parentheses. Please do not distribute the 8 to the negative 4W. It's not in parentheses, okay? So that's going to give you 16W minus 8 minus 4W equals to negative 116. Now, if we were in class, what I'll do is I'll work some of these. I kind of bounce around. And then I say, hey, I think you all need to practice. So I'll let you practice with a peer. Or some people like practicing on their own. And then we would check and see if you were getting them correct. And I kind of walk around and help. All right, so you're going to have 16W and minus 4W. And I'll tell you what, you can pause the video right here if you want to, and then see if you're getting it, and then unpause it to see, if you actually got the right answer. All right, 16W minus 4W is going to give us, 12W minus 8 equals to 116. And then you're going to add 8 to both sides. And I just like drawing my line. So it's going to be 12W, or 12 times W equals to 124. And I'm going to have to go up here and just rewrite it because I'm out of room. Divide both sides by 12. Oh, I wrote that wrong. Let me go back and look at this. Oh, okay. Never mind. I see where I made a mistake. All right. I made a mistake, guys, because I know that wasn't working out. Okay. It's negative 116. I wrote 116. That's my fault. I'm sorry. Some of you probably caught it when I was doing the video, because that's going to be negative 108 then. Then you're going to divide both sides by 12. So W is equal to negative 9. Okay, that's much better. Okay, I want you to pause the video and you try number 7. But remember, if you see parentheses and there's no number sitting right next to that parentheses, what do you write? That's right, you put an imaginary 1. Put your 1 there, and you're going to distribute that 1. All right, you pause the video and try it. All right, I've assumed that you paused it and tried it, so here we go. So 11H. You don't care about 11H right now. You're just using the distributive property to get rid of these parentheses. Negative 1 times 2H is negative 2H. Negative 1 times negative 1 is positive 1. And I'm going to combine like terms. I do have like terms. There we go. That's going to give me 9H. I wanted that to be black. 9H plus 1. It's a bad 1. Equals to 118. You're going to get rid of the one that's farther from the variable by changing the sign. So I'm going to change positive 1 to negative 1. These will cancel. So that's 9H equals to 117. The opposite of multiplying H by 9 is, of course, dividing it by 9. Remember, we're not changing the sign unless we're getting rid of the one that's farther from the variable. The other stuff stays, okay? So we got 117 divided by 9. So H is equivalent to 13. If you have to, if you don't have your calculator, just come up to the side and do it the long division way. It goes once. You get one group of 9 out of 11. Your remainder is 2. How many groups of 9 do you got of 27? That would be 3. And that's that. All right, so I'm going to move on lastly to the fractions, and then that's going to wrap it up, okay? If you have a fraction, you still can use the distributive property. All right, so I'm going to use the distributive property here. I think I got ahead of myself. All right, so this problem is more like the other ones we've been doing. We're just distributing a fraction. So you have 1/2 of 10. Everybody knows 1/2 of 10 is 5. But you can do this. Of means multiplying. You take a fraction of another number, you multiply. So basically you end up with 10 halves, which is 5. So when I multiply here, I get 5x. And then it's 1/2 of -2. But you all should know half of -2 is -1. But if you do it this way, it's -2 over 2, which still gives you -1. Say -1, right, minus 1. Plus 3x equals to -25. Now I'm going to combine like terms. All right, these two are like. So I get 8x minus 1 equals to -25. Excuse me. All right, the -1 is farther from the variable, so you're going to add 1 to both sides. So we'll end up, I'm having to go up here, with 8x equals to -24. That's a negative. Divide both sides by 8. The opposite of multiplying x by 8 is dividing it by 8. But what you do to one side, also do to the other. So you get -3 there. All right, so this is what I want to do. Now I want to go to the one that has multiple fractions in it. If it has multiple fractions in it, you can remove those fractions. Because some of you are probably looking at this problem right here on number 1, where it has solving two-step equations with multiple fractions. You're probably looking at like, what in the world is that? Some of you would just go through and find the common denominator and work it with the fractions. And you can work it that way. It's totally up to you. But I don't want to. So what I'm going to do is get rid of the fractions. So I'm going to look at for a common denominator for 3, 10, and 5. If you're in my advanced class, you should already tell me a common denominator. It doesn't have to be the smallest one. I just need a common denominator. Let's start listing the biggest one first. Okay, so I already know with 5s, I'm eventually going to get to, that's a 15. Y'all, it's the pen. It's not me, okay? I'm recording this on Screencastify, and it's making all of my stuff like be in slow motion. So I'm just listing multiples, 5, 10, and then of course 15, 20, 25, 30. I see a 30 here and a 30 there. The question is, will I get to a 30 over here? Yeah, you're going to get to a 30, okay? Y'all should know. I mean, you all probably already knew beforehand. All right, so what I'm going to do is, with that 30, I'm going to multiply each one of these by 30. And I'll show you a little trick on multiplication too, when you're multiplying with these fractions over here, okay? So let me change color. Let's do it in purple. So I'm going to multiply by 30 here. I'll multiply each one of these by 30, all the way through the equation, even go over here, even go on that side. So everything has been multiplied by 30. What I would do is I'd say, well, how many times does 3 go into 30? Well, that would be 10. So you would end up with 10x, because it's still 10 times x. How many times does 10 go into 30? Well, that would be 3. So now it's -1 times 3, which is -3. All right, how many times does 5 go into 30? Well, that would be 6. So now you have 3 times 6, which is 18. And I've gotten rid of the fractions just like that. Again, this is what I did. I said, how many times does 3 go into 30? So I'm right here. How many times does 3 go into 30? That was 10. So 10 times x leaves me with 10x. How many times does 10 go into 30? That would be 3. 3 times -1. Look at this, is -1. Would be -3 or -3. How many times does 5 go into 30? Well, that would be 6. Take that 6 and multiply by your numerator. 6 times 3 is 18. This is the cross-canceling way, okay? Now, some people are not going to like the cross-canceling way. So I'm going to show you another way, okay? If you got the cross-canceling way, just keep working your problem. I'm going to show you another way. You still got to multiply each one of these by 30, okay? So basically, you could just look at the top part and say, okay, this is 30x. Well, what is 30x divided by 3? So 30x divided by 3 is just 10x. So here I get 10x. You don't have to cross cancel. Then you could look at this. You could say, oh, that would give me 30 on the top. Well, what's 30 divided by 10? Okay, that's 3. So you just put your minus 3. And some people are going to look at it and they're going to say, look at this part. That's 3 times 30, which is 90. Well, what's 90 divided by 5? Okay, well, 90 divided by 5 is 18. So you can either cross cancel or you can just multiply the two numerators and divide it by your denominator. It's totally up to you. If you cross cancel, you're doing the opposite. Instead of multiplying the numerators and dividing by your denominator, you're dividing your multiple. You're dividing first. You're dividing your multiple by your denominator and then multiplying the leftover by your numerator. But it's completely up to you. All right, here I have a two-step equation. So I'm going to get rid of the one that's farther from the variable. So I'm going to get rid of the negative 3 or the minus 3. So I end up with 10x equals to 21. Divide both sides by 10. And x is equal to 2 and 1/10. Or you could put 2.1. It's the same thing. Okay, sorry about that, guys. It's just not writing right. It's 2.1, 2 and 1/10. All right, let's take a look at 2. 2 will have 4, 2, and 8. And like I said, you all should know this already. 2, 4, 6, 8. So I get to 8, okay? So I'm going to use 8. So I'm going to multiply each one of these by 8. Try to get a different color. Okay, forget it. Okay, multiply by 8. Multiply this one by 8. Remember, you're multiplying everything by 8. You even going on this side of the equation and multiplying by 8. All right, so I'm going to look at this as 24 divided by 4. 24 divided by 4, which is 6. So that gives me 6e. And then I'm going to look at this as 1 times 8, which is 8. Okay, 1 times 8 is 8 divided by 2. But what is 8 divided by 2? It's 4. And here, I'm just going to cross these 8s out. They cancel each other. So that leaves me with 7. You could have said, well, what is 56 divided by 8? You still get 7. It's up to you. Now, the one that's farther from the variable is 4. So we're going to get rid of the 4 with a minus 4. So you have 6e equals to 3. And divide by 6. Well, e is equal to 3/6. But 3/6 equals, in simplest form, is 1/2. Okay? And let's take a look at this one. And remember, you can pause the video and try them at any time you want to, okay? It's totally up to you. All right, you got 3, 4, and 12 as your denominators. We're just looking at the denominators. So you have 3, 6, 9, 12, 4, 8, 12, and then 12 here. So it's 12, 12, 12. That's the smallest one I can find. So I'm going to multiply each one of these by 12. All right, so you can say 24 divided by 3 is 8, or you could look at it this way. You can do 24 divided by 3 is 8, or you could say 3 goes into 12 4 times, and 4 times 2 is 8. Totally up to you. 36 divided by 4 is 9. And I'm just going to cancel these out. They're the same, leaving me with that negative 7. So I'm going to get rid of the 9 with a negative 9. It's farther from the variable. So you have 8r equals to negative 16. Divide both sides by 8. And r is equal to negative 2. And that's all you do. Now I want you to try number 4. And then pause the video and try number 4. This is the last one before you actually have to do your exit pass and the homework. Now you're going to have to turn in your exit pass and your homework The exit pass is labeled, I think it's number 3 under Google Classroom for today's lesson, and the other one may be labeled as number 4. I don't know what number they'll label as, but it's gonna say exit pass and homework. Make sure you submit both of those by 11:59 p.m. tonight, okay? Pause the video and try 4. All right, I'm gonna unpause it. I hope you've unpaused it. Let's take a look. Your common denominators are just 5 and 2. So everybody should know, of course, that's 10. Blah, 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 10, okay? So I'm going to multiply each one of these by 10. Even the 5 gets multiplied by 10. Remember, I said you even go on the other side. So you're going to end up with 20 divided by 5, which is 4. That's 4x. 10 divided by 2, which is 5. 5 times 10, which is 50. And I'm just going to add 5 to both sides to get rid of the one that's farther from the variable. So 4x equals to 55. Divide both sides by 4. And how many times does 4 go into 55? Okay, 13. Let's see. Let me go over here and do it, because it's going to be a mixed number. It goes once. That's a 4. Bring down that 5. 4 goes into 15 3 times. It's 12. Subtract that. So basically, I'm looking at 13 and 3/4. 3/4 as a decimal is 13. It's 0.75. So you could simply write 13 and 75/100. It's totally up to you. Decimal or fraction. And it's just whatever you want to do, okay? All right, so what you're going to do now is you're going to go to Google Classroom. And this exit pass is on Google Classroom, separate from this. And I think it's 9 questions on the exit pass. It is. But just go to the Google Classroom, do your exit pass, submit it. You can do the work on notebook paper, scan it, and upload it to Google Drive for me, okay? Then submit it to Google Classroom. And do the same thing for your homework. Both parts are due by 11:59 tonight. So this is going to let me know what I need to be doing with you tomorrow, okay? All right, that's it, guys.